Hello friends, today I'll be looking at polynomials in mathematics, the remainder theorem. Now, for instance, the remainder theorem is all about if you have a polynomial expression, function of x, and it's divided by a linear expression, if function of x is divided by, for instance, a linear expression like x minus a. Now this is a polynomial expression. There's an expression as function of x and it's divided by dx. Now the remainder is equal to f, function of a is equal to the remainder. Now the remainder is equal to this. So why? Because if you equate this into 0, x, making x the subject of the formula, is going to be a. So when you replace this a with, we replace x in the expression, the main polynomial expression, with a. So whatever you are going to get will be equal to the remainder when this polynomial expression, when the expression is divided by this linear expression, x minus a. Similarly, if function of x, that is a polynomial expression, is divided by p times x plus q. This is the linear expression. P is the quotient of x, is divided by this. The remainder is going to be function of minus q over p. This is going to be the remainder. Will be equal to r. That's the remainder. This is the remainder. This is going to be the remainder because this is the divisor. This divisor, if you equate it to 0, making x the subject of the formula, you're going to get minus q over p. So I'm going to use some examples to explain this further. Now, example 1. If 2x raised to the power of 3 minus x raised to the power of 2 minus 1 is divided by x plus 2, what is the remainder? What is the remainder? Now, looking at this, what is the remainder? I'm going to apply the remainder theorem. Now, solution. This is very simple. I'm going to write function of x. This is the main polynomial expression, 2x raised to the power of 3 minus x squared minus 1. Then from this is the divisor, the linear divisor. Now what I need to do is to bring it, if you equate this into 0, so I'm going to have x as minus 2. Equating this into 0, this x is equal to minus 2, because if you make x solve the formula, when you equate this into 0, it's going to give you minus 2. So I'm going to solve with minus 2 as the value of x. So whatever I get will be equal to the remainder. That is all about the theorem. Now, in this case, I'm going to replace x in this expression with minus 2. Doing that is going to be 2 times minus 2 raised to the power of 3 minus 2 raised to the power of 2 minus 1. This is the same thing as 2 minus 2 raised to the power of 3 is going to give me minus 8, because it's minus 2 times minus 2 times minus 2. Minus times minus is plus. 2 times 2 is 4. Plus 4 times minus 2. Plus times minus is minus. 4 times 2 is 8. So that is why it is minus 8. Now minus 8 minus, but this one is going to give me plus 4. Minus 2 squared is plus 4 minus 1. So this is the same thing as 2 times minus 8 is minus 16 minus 4 minus 1. Minus 16 minus 4 is going to give me minus 20. Minus 20 minus 1 is going to be minus 21. So the remainder now, when this expression is divided by x plus 2, is going to be minus 21. So assuming that this is a factor of this, or it's not a factor is when this is divided by this and there's no remainder, you now know that x plus 2 is actually a factor. But since there's a remainder, there's no had it been if this is a factor, this is going to give me 0. Now, so I'm going to look at the second question, the second example. So the second example says the polynomial x raised to the power of 3 plus ax raised to the power of 2 minus 3x plus 4 is divided by x minus 2 and the remainder is 14. This is 14. What is the value of A? Now, looking at this, it's very simple. I'm going to use the theorem again here because this is the divisor. It's actually a linear divisor, and this is the polynomial expression. And they said when this polynomial is divided by this x minus 2, that the remainder is 14. And remember, there's a here and a non-variable. So what I need to do is to write solution. So how do I go about this? I'll bring out function of x, which is this. It's going to be x raised to the power of 3 plus ax raised to the power of 2 minus 3x plus 4. So now remember what I normally do here. So the value of x is going to be, I'm going to replace x with what here? This is going to be 2, using remainder theorem, because if you equate this to 0, x is going to be 2. Okay, I'm going with 2. Anywhere I see x in this very expression, I'm going to replace with 2. And remember that this is equal to the remainder. Okay, so I'm going to equate everything here with r, because when I replace with 2, so everything I get is going to be equal to the remainder. Now, so anywhere, that means function of 2 is equal to 2 raised to the power of 3 plus a times 2 raised to the power of 2 minus 3 times 2 plus 4. It's very simple. Now, this is the same thing as a square is 4. 4 times a is 4a. This is 2 raised to the power of 3 is supposed to be 8. I'm going to write 8 here plus 4a, because 2 raised to the power of 2 is 4. 4 times a is 4a minus 3 times 2 is going to give me 6 plus 4 will be equal to 14. This is the remainder. Remember, this is equal to this. I'm going to equate this whole thing to 14. So this is going to be 8 minus 6 is going to give me 2. 2 plus 4 is going to give me 6. So I will write 6 here. 6 plus 4a is equal to 14. Okay, now what I need to do again is to collect like terms, make a the subject of the formula. Now collecting like terms, 6 will make 14. That is going to give me, that is going to be 4a is equal to 14 minus 6. 14 minus 6 is supposed to be 8. Now making this is 4a is equal to 8, and you know, when you find the value of a is going, you divide both sides with the equations of a, which is 4. 4 will cancel out 4. You have a is equal to 8 over 4, which is 2. So the value of 2a is equal to 2. Thank you for watching. Don't forget to subscribe to this channel for more.